Antiderivatives and the indefinite integral. One page of algebra. Okay, integration. Another word for integration is anti-differentiation. Integration or anti-differentiation is just like you're doing the reverse step of long word. Yeah, differentiation. Yeah. So it's like you're doing the reverse step of differentiation. Differentiation. One thing. Yeah, good. Okay. Krista, this is new hard stuff. Okay, Krista.
Yeah.
Look,
you want me to? I'm sorry.
One thing you need to remember is that the answer has a constant. The answer has a constant term in it. E.g., see the constant terms like e.g. -6 or minus 8. If there's no number written there, you just say the constant is 0. That's all. So if there's no number written there, we don't so much say there's no constant always, but we just say the value of the constant is 0. So, so the answer will have a constant term in it. If we don't have enough information to work out what that constant term is, then we just leave it and we just call it C. Notice it's uppercase C.
Or
Constant.
Did you really make us just write that 3 times?
Yay. And so notice it's uppercase C. When I was in Australia, we had to write lowercase c.
We're always in Australia.
Back in those days.
You're always talking about Australia.
In Australia.
You've been home, Miss Helen.
It's alright. Yeah, I haven't lived in Asia before though.
Oh,
Or
so
Latin
you
America.
just like so used to just say
You
my
live in
family.
Africa?
You just so used to just be like my family. Like,
You've gone to South America? You've been to South America and Africa, like lived there?
No, I've not lived there, no. No, the one, Miss Wilcott, she's one like that. And she's lived in all these different continents and stuff.
That's cool.
Miss Wilcott. She didn't live in Africa though. But that's probably one of the only ones.
And Antarctica.
That too. Or Australia. Okay, so so we call it C. Notice it's uppercase C. As I said, in Australia, we would have to use lowercase c, but here they use uppercase. How did I first realize this when I first had to teach this years and years ago? I saw on the formula booklet. Oh, that's not it. On the formula booklet, I saw, oh, look, uppercase C. How about that?
So was I right?
What about the joke? That's a good point, I should say. So, Talise was curious about one of the jokes. What's this C all about? It's a constant term, yeah.
evil is constant.
But then why is it lowercase?
In life, big question.
Australian. It's an Australian.
It's been Aussie, yes. Evil plus constant. See, it's just evil.
Constantly evil.
Not necessarily.
And what about this one? Here's the integral. The integral's at a Chinese restaurant. It looks a lot like what's that one in Reed Street?
Chopstick?
Chopsticks. It looks just like the booths in Chopsticks. So the integral is in Chopsticks. It's had its meal, it's paid its bill, and it's been given a fortune cookie. And this is what the fortune cookie says.
By taking many small steps, but it comes.
And they look up, and they don't look happy. I don't know. I think just because they're disappointed. Huh? Do you think? Notice the joke is I see integrals.
I don't understand.
Where do you see integrals here?
How often all the time?
Oh, the thing. The swish.
The what?
The swish.
The S?
Yeah.
Where's the swish? See soda, the word soda?
But I don't understand the was. Because I see integrals everywhere. You see it in the S.
Oh, so what it's done is find the integral of the function. The function would be O, and dA means with respect to A.
Oh.
dA means with respect to A.
Is that DA? Where's DA?
dA in the soda. Find the integral of the function O with respect to A. And that's what the answer would be. Okay, back to here. All right, good. We've got That's an hour slow, still good, thank goodness. We've got 20 minutes. Okay, see, examples, anti-differentiate the following. So see the different ways they are asking the same thing. Anti-differentiate the following, integrate the following, find the indefinite integrals of the following, and I've used the crazy symbol, find the integral of this function with respect to x. But these ones are nice and easy. Anti-differentiate the following. So if, for example, if the derivative, like try to think what the reverse step would be. If the answer to differentiating was x squared, what would have been the exponent on x in the original?
X3.
X cubed, yep. So that's the first thing. So you need to add 1. You need to add 1 to the exponent. So it's going to be x cubed. But if you differentiated x cubed, you would have gotten 3x squared, wouldn't you?
Yeah.
So what should we put it over so that the 3 will cancel out? So just give us 1x squared.
3.
Over 3, yeah. And I need to write it a bit more to the side because I need to add in something. Just something very small that's easy peasy to forget. So it's going to be x cubed over 3. That's x cubed over 3 plus
C.
big C. That's it, yeah, plus C. So notice they've all got plus C. Because if you differentiated this, so you would get 3x squared over 3, because that's like a third. 3x squared over 3.
So we just anti-differentiated x squared.
Yeah, that's the answer.
How?
Right there. It's like imagine that's the answer after you've done like your regular differentiating. What would have been the question? So what thing when differentiated would become x squared?
X cubed over x3.
Over 3, yeah. Because 3x squared, and then the 3 divided by 3 would cancel out to give you x squared. Yeah, so you add 1 to the exponent. That's the first thing. Add 1 to the exponent. But then, for it to just be like 1x squared, we'd need to cancel out. Because when you differentiate this, you'd get 3x squared over 3. And then the 3 over 3 cancels to 1x squared. Plus, there could have been a constant term. We don't know. Oh, well, you know, there probably was a constant term, but maybe it was 0. But because we don't know what the value of the constant term is, we just write plus C.
So you would, because if that was going to be 3x, but then since it's over 3, they would cancel into 2x squared.
Yeah, exactly.
Okay.
Yes.
Just add the C just to...
Yeah, because there could have been a constant term that's not 0 there.
I apologize.
Sorry, just putting it over here.
Wait, are all done now?
Oh, yes, sure thing. Sorry, just trying to put this nice and small. There you go. So I can fit. I just say I've got a bit of space because you know these boards are a bit wacky. So I'm just trying to give myself a bit of space for the others. I might write a bit bigger. I might just zoom in a bit more. There you go, that's going to help. So I'm just zooming in a bit so I can write a bit easier. And to differentiate the following. Okay, so cool. So x cubed over 3 plus c. That's just a constant.
X cubed.
Yeah, so what would be the next one? What would be the exponent, Bella, on the x?
4 over
x4. Yeah, makes sense, doesn't it?
C.
Yep, plus c.
4.
Plus c, yeah.
And then
Yeah.
the next one, x
It's
cubed.
just lying. Yeah, because that would give you 4x cubed over 4. 4x cubed over 4, which cancels out to x cubed. Anyone want to suggest the next one? I think you know what you started.
X8 over 8 plus C.
Yeah. X8 over 8 plus c.
And then the next one.
Yeah, there's 2 terms, so just separately do them, yeah? Like you do with differentiating. That's it.
No, it's x4
That's it.
subtract x squared over 2. What?
Yeah, over 2.
Oh yeah, so you did the whole thing over 2.
Yeah.
Yeah, if you did it separately, imagine it was just this one to start with.
Wait.
2x cubed. You can just do them separately like that. So I just tend to look at them. Oh, that's not the answer. Just look at them one at a time. So you know it's going to have an x4, don't you? So you know for sure this bit. Oh, hang on. Oh yeah, that one's over there. So you're going to have an x4. If you want, like, think it's 2x cubed, 2x4 over 4, and then you could simplify it in the next step. So see, you can just rewrite it, x4 over 4.
This one, why is there 2?
Oh, this is going to cancel down to a half.
Oh, because then you have to cancel over the 2 that's right there.
Yeah. So what I tended to do is notice that the new exponent is 4, so put it over 4, but then that just means that this is going to cancel down in the next step. So still like we did before, raise the exponent by 1, divide it by that exponent, that new exponent, but then maybe like cancel down in the next step. So so the original one is just x1 here, so minus. What will be the new exponent? What will be the new exponent on this one? 2, good. So I should put it over. Over. 2, yeah, that's right, over the new exponent, yep. And then maybe in the next step do any cancelling down. Oh, and don't forget, I always forget this, so be careful. Plus c. I'm a shocker for forgetting my plus c. So you guys don't do my bad habits. So 2x4 over 4, what does that cancel to? Yeah, a half x4 or x4 over 2, that's the same thing. So a half x4 or x4 over 2 minus x squared over 2 plus c. You could, if you're in doubt, you could try differentiating it.
Yeah, Kathleen?
Yeah, so what would be the derivative of a half x4?
4x3.
4x cubed over 2,
Yeah.
which simplifies down to 4x
2x cubed.
Yep, yes it does. Yep, good. It's good to test it that way. Yeah. What would this one be when you differentiate it? 2x over 2, which cancels down to not take away 1x. Yep.
Isn't that what I said?
Similar, but and then maybe you cancel down afterwards. So you could write it like this, or you could kind of write it like, or a half. Oh no, what am I saying? So you could write it as x4.
Oh my god, making this make ranted in about a couple of years.
So what Sarah was saying, I think, was something along the lines of this, maybe, when it's simplified. So notice there's 2 ways. That would also be acceptable to write it like that, but you're just as fine to write it the first way too. Yeah, Sarah was kind of thinking like the combined style. You see, they're both over 2, so you cancel these 2 terms over 2. The c is not over 2, so leave c out of the over 2 business. So it's pretty good fun. A common error just is forgetting the plus c. Just be aware of it. Try to sort of keep it in your working out so you don't forget it at the end. So next one, integrate the following. So now we've got to be thinking of fractions.
Wait, these are your last one.
Oh, is there more?
Yeah.
I just couldn't see it, sorry. Oh yeah, there's another one. Oh yes, there it is. Sarah, what would be 5x4? We'll give you a new exponent.
5 over 5.
Yeah, over 5.
Plus
Yep. So now constant term, guys. What's a constant term?
7.
Close.
What?
Oh, plus when it wasn't
See?
close.
Oh!
7x. Yeah. How did you get 7x, Paige?
That's the answer.
That's the answer.
So if you differentiated that.
Yeah, exactly. Yeah. Because if you differentiated 7x, you would get 7.
we know
Now
5 over 5 is 1.
5 over 5 is 1. Yep, good. So we just write x5 plus 7x.
Hey, did someone was gonna see Catherine and just standing right here outside the green light? If I record it right now, I would record it if I could.
Okay, so you got that one? So that's important. Like if it was a constant, its previous one would have just been the coefficient with an x next to it. And continuing on, that's lovely, that
I have
rain.
to walk on the other side.
Miss Erin?
Wait, can you go back up, please? I wasn't done writing.
No worries. You go.
Someone was like,
There you go. If you're still writing, you can still write it. We just went back up.
Miss May, are you going back to Australia for
No, I'll be going back in July for my mother's 80th birthday.
Wait, so you're going to stay here for Christmas?
Yeah.
That's sad.
And then yeah, just a bit. But no, Elbow Beach is nice.
You have
I've been here
friends
once.
Here.
Yeah, and I have been here once for Christmas and it was good. And then I'm going to Florida Keys,
Over Christmas.
New Year's.
Is that like really hot?
No, not that hot. Won't be much.
It's gonna be like summer there.
It'll be some, yeah, it would just be a little bit warmer than here. Yeah, I just want to see it. I want to see the Florida Keys.
Yeah.
That is so nice. It's like tropical rain, isn't it?
Tropical rain. Tropical rain.
Why are you seeing
This is tropical rain. Not a sun shower, but tropical rain.
Okay, guys. So now we're getting into the slightly trickier ones, which you've got to remember fractions. So we need to still just add 1. So think of it as like 7x. What's half plus 1?
1.5.
1.5 as an improper fraction.
3 over 2.
3 over 2. 3 over 2. There you go. So 3 over 2. So trying to remember how you add fractions. So like 1.5. 1/2 plus 1 is 1.5, which is 3 over 2. And then so therefore, because I'm dividing, because I'm doing this, I am also going to divide by. Because that's what we always do.
Yes.
And don't forget the little plus in there. See, I'm starting to forget already, aren't I?
Yeah.
So when you're dividing by a fraction, it's the same as multiplying by the. Yep, reciprocal. So we've got to think of. So Bella. 7 divided by 3 over 2 is the same as doing 7 times 2 over 3, yeah. So 7 times 2 over 3. So if you want, you can kind of like, you might want to do that on the side, or you might want to do it here. So 7 times 2 over 3. Okay, I'll just have to do it here, sorry. So you might just want to go, or do 2 over 3 like this. How did suddenly that just become 2 over 3? Guys, are you writing this? Because we want to be able to move on. Then plus c. So you might want to, on the side, work out 7 times 2 over 3. That's okay if you want to, but I'm not able to write easily with this board. So what's 2/3 times 7? 2/3 times 7 over 1. Oh, not with calc. If it was non-calc, what would you do?
14 over 3.
Yeah, 14 over 3. So you could go like 14. You could go 14 over 3, x to the 3 over 2. Or you can go 14 x to the 3 over 2 over 3 is also okay. Move out of the way. So you could have written 14 over 3, x to the 3 over 2 plus c. Or you could write 14x to the 3 over 2 over 3. That's okay.
What's the difference? You just 1 divided by c? Did you just say the same thing?
The other way, I'll just write it here, and I'll erase it though. So I'm having trouble writing here. 14 over 3. Like that. So you could have also, see how it's okay to have written it like that too. You might tend to find in the book, I think they've got it in my way you read, more so in the book. So that way is okay too, where 14 over 3 is written out as a coefficient. Also, they're the same thing. And I don't have much width, so it's a bit narrower if I write that way. What? Okay, cool. Let's go back up to here. Okay, so these ones, before you find the integral, you might want to rewrite it. Square root of x is the same as x to the power of something. Close. Good guess though. It's good to think like that. Owen, Bella, pay attention please. This is fun. Close, really close. Square root of x is the same as x to the power of? A half, yeah. Back to your exponent stuff, isn't it? So that's just still the original. That's still the original. Now we're going to find the integral, the indefinite integral. So now we need to, similar to this one, we need to add 1. So we haven't integrated yet. We've just rewritten the original function. Okay, so what would be the new exponent? Yeah, x to the 3 over 2. Yep, divide by 3 over 2.
So wouldn't plus 1 just be 2 over 2?
Oh, that's plus a half. A half plus a half, yeah, is 2 over 2. Good that you're thinking about this stuff. Because it's like
Can
saying
you just tell me I'm wrong?
1 plus 1. So yeah, half plus 1 is like a half plus 2 over 2, which is 3 over 2 kind of thing. This is if you've got any space and you want to write that. Okay, so now we've got to do, so dividing by 3 over 2 always is the same as multiplying by, or anyone can jump in?
What did you say?
Dividing by 3. Yeah, timesing by 2 over 2. Dividing by 3 over 2 is the same as times.
X 3 over 3.
Okay, good. So I don't have much space to do little bits of work on the side, but if you're doing stuff from the textbook, you could always do that, do the fraction working out.
Esa
on the
tengo
side.
para ir, ¿sí? I say this every class.
Okay, so what would these two be? What would that one be written as?
No, esa tengo para ir. Nobody say anything.
X to the power of
1 over 3.
1 over 3, yep.
Sorry.
So, and what would that one be? X to the power of?
4 over 3.
Close?
3 over 4.
3 over 4, yeah. And then we'll find the integrals of those next step.
6 over 1.
Well done, good work.
It's another question. Is it negative 6?
Oh.
Negative 6, isn't it?
Yeah, negative 6, yeah, good. Nice work. Okay, I'll put